Okay, so now let's go to our PhStat, and I want to demonstrate a couple of things here and what we did in the class. So here, let's choose from PhStat the two sample tests and summarize data. And we have the two sample tests for differences in proportion, which is what we did, okay, in class. So z-test for differences between two proportions. So let's just do that, see if we get the same solution with the example we did in class with the difference between male and female voters. So here the hypothesized difference we indicated as 0. Population 1, that's the male voters, okay, number of items of interest, and that was 36. So 36 people said they would vote for the proposition in a sample size of 72. And in the females, we had respectively 35 and 50 here. And we are doing a two-tail test and hypothesis testing significance level is 0.005, which we could change. Let's also take the confidence intervals for the difference. Okay, and what we see here, again, the same results. So the blue places actually could be used to enter our data, and the proportion in the male group, 50%, proportion in the male group, 70%, which gives us point estimate for the difference as 20%. So females voting 20% more in favor. Okay, and this is the pooled proportion. Okay, the proportion which is calculated by taking the sum of yes votes overall, dividing it by the total sample size, including males and females. So that's 58% overall. And the z-test statistic, which you can calculate using the formula seen here, the critical values using 0.005, okay, and the p-value, okay, which is lower than our stated level of significance, so rejection of the null hypothesis. Again, let me go over these points as well. So here the same z-value, standard error of the difference between the proportions calculated with the formula you can see in the formula bar. Okay, and interval half width and the plus and minus. So then we should add 20% plus that and 20% minus that. And even when you subtract 17% from 20, so again, there is an interval here from a difference of 2.8% to 37%. This is in favor of more female votes. So this doesn't include 0, hence we reject the null hypothesis. Okay, one other thing we did was to see if the population variances were equal. And this was a condition. Remember here, we have a t-test, okay, assuming equal variances and not assuming equal variances. So to do that first, we need to test the equality of the two population variances, which can be done using this option, f-test for difference in two variances. Okay, so let's invoke that. So population 1, and remember our New York Stock Exchange and NASDAQ example. So population sample size was 21. Okay, and the sample variance was, now I have to calculate this 1.30 squared. Okay, so that's 169. And I'm entering it right here, 169 sample variance. And sample size for the second one was 25. And it was actually 116. So what I'll do now is 116 square, 1.3456. Okay, and it's a two-tail option, and you can see now we don't have the lower tail as consistent in our slides because F distributions are generally in the books. We have the right tails provided. Now we can calculate the left tails, but it won't be necessary if you actually take the convention of making the first one the bigger one. Okay, so the two-tail test, when we say okay, these are the values we entered, and here we have do not reject the null hypothesis. Okay, degrees of freedom. Normally you should check the F table, numerator degrees of freedom, denominator degrees of freedom. Okay, and upper critical value is taken from the F in RT, which is right tail, dividing alpha by 2 here. And we have the p-value here. Okay. All right. And here we have the, again, one of those intermediary calculations. Okay. Okay, there is some mistake we did. Apparently, because we used, okay, we have to do this again because we used the comma and the variances we entered were taken directly as 1. Okay, so let's just, now this is a good thing. Let's do this one more time. Okay. So it's a good thing maybe to demonstrate we could also do a mistake. So this was 21 and sample variance was 130 square, 169, but I have to enter it using the dot. So because I used the comma, it didn't work. Okay, so we have now here 25. Okay, and we need to calculate 116 squared. $1.3456. So again, 1.3456. So normally our systems use the comma, but to enter into this dialog box, we need to use the dot. So now we're going to get the normal. Okay, now we got the normal values. The previous one was a mistake, maybe a good demonstration that if in those boxes you use the comma and the decimal separator will not be recognized. So you just get whatever that's before the comma. So here again, we have do not reject, but now we have the correct F statistic, the ratio of the two variances that we provided, degrees of freedom. Okay, the F critical value, 2.32. So 1.25 is less than 2.32. So if it's in the not reject region, and here we have the p-value much larger than 0.005. So we have no reason to reject the null hypothesis that the variances of the population are actually are different. So equality of variance assumption is not rejected. Okay, so that's the result of this test. So let's go back.